Right then everybody, so here we are on the aircraft finally. We're going to start the cockpit preparation checks, which ensure essentially that all the various systems are tested and initialised for departure, and we have all the requisite emergency equipment and charts on board as well. So first things first, when we arrive at the aircraft we need to make sure that the pins and covers are stowed. Now in the Pro version of the Q400 you remember that the gear pins are actually simulated, and if they're stowed they'll be placed in the little receptacle there behind the first officer's chair, which they are, so we can assume that they're stowed. We've also sent the first officer out to do the external inspection. So next we're also making sure that the parking brake is set to park, the lever is in park, and we're also ensuring on the first officer's side that we have sufficient hydraulic pressure in the parking brake system, which we do. We also need to make sure that navigation lights are selected on. They're known as position lights in the Q400, but those, as I've already discussed with you in previous videos, are the red lights on the port side, green on the starboard side on the wing tips, and they need to be selected on at this point. And we also need to make sure that the various circuit breakers are stowed. We have pop-up panels on the Pro version of the Q400 of course, which give us all the various circuit breakers for the systems on board the aircraft. We just need to give them a cursory overview to make sure that none of the circuit breakers have been pulled. So next we can get seated and get comfortable. Obviously the first flight of the day does have to be quite thorough, and the panel scan as part of the cockpit preparation starts from the top left of the overhead panel, moves in a W shape over to the top right. Thereafter the captain's scan starts for the left hand console down here, the glare shield, the main panel, the pedestal, and the first officer's console, finishing at the gauges here on the right hand side. So let's start with our checklist, shall we? Cockpit preparation check first of all says documentation, which we need to check. As I've said to you, we're using the aerodrome charts from the UK AIP website, which can be very easily found via Google. We also have our operational flight plan, which we've saved, and we'll be looking at that of course throughout the flight, and also checking we've got the various checklists and manuals on board as well. Safety equipment, we have all of that on board, and the next check we need to complete looks at the landing gear and pins. So we need to ensure that the gear alternate release door, so we need to check that the main gear lever under the gear extension panel in the cockpit floor is stowed. Check with the light selector that the gear down indications show normally. Turn that off and then close the panel. We also have to make sure that the gear alternate release door is closed and the down select switch is guarded. So with those initial checks done, we can start with the overhead panel. As I said to you, we start in a W motion around the panel. So we commence therefore with the DC control panel. All of the battery switches should be selected on, including the battery master, and we do need to check the voltage. Don't forget, for engine start require 26 volts with external power connected. And as you can see on the electrical page of the multifunction display, we have DC external power connected and feeding the buzz bars, and the various DC buzz bars have 26 volts at least on each side, so that's perfectly sufficient for engine start. If we're starting from batteries only, then we need at least 22 volts fed to the DC buzz bars, and as I've said in a previous video, starting from the battery is not a standard operating procedure, but is required if external power or the APU are not available. We also need to check the temperatures to make sure that they're not above 25 degrees, and as you can see they're well below that, which is good. Back up to the panel then, checking the main bus tie is selected on. The external power is selected on as well. We need that at the moment, obviously, to supply the buses with DC power. We could use the APU, but as I said in a previous video, because it's noisy and it uses a fair amount of fuel, we try and use the external power where possible. And also making sure that the DC generator master switches are selected on as well, so that when the engines come online, they can immediately provide us with DC electrical power. The ice protection, essentially all the various switches on this panel need to be off at the moment prior to engine start. The engine intakes need to be open with the amber light selected, and all the windshield selections can be off at this stage. Having a look at the external lights now, obviously the landing and taxi lights aren't required at the moment because we're sitting on stand with the engines off. The locator transmitter is in the armed position, which is perfectly satisfactory, and if we perform a ground test of the flight data recorder, if we select the switch to ground test, you should see the data recorder light on the caution and warning panel here on the top right will hopefully extinguish. There it goes. And when we select it back to norm, the light is illuminated once again, and we get the master caution as expected. Altimeter units, we can keep those in feet. We don't use meters in Europe as a rule. And next, we're going to look at the fire detection. Now, as some of you may have already seen, there is a dedicated video covering the fire detection systems on the Q400, which also goes through the indications we're looking for on the test. So I'm not going to go through all of that now. I'm just going to carry the various tests out. And if you want to know exactly what we're looking for, you can have a look, if you're a member of Virtual Flybe, at the expanded checklist in the pilot's library section of the website, or you can have a look at the fire protection video. But because it is a bit long-winded, as I say, all I'm going to do is simply carry out the tests for filming purposes. So here we go. The APU test, first of all, making sure the APU is selected off, of course, because if the APU is running and we use the fire test function, then it'll simply shut down automatically. So selecting the fire test, all the correct indications, the correct caution and warning panel indication, and the master warning light as well. That can be selected off. Next, the engine indications. Engine 1 first of all. Master warning there, and the engine fire push button resets the warning horn when depressed, so that's all working correctly. Next, engine 2. Yep, so all indications working normally so far. We check the baggage fire as well. Number 2 first of all. Number 1. And the forward baggage area. All indications working normally. So the fire protection system is looking good. The panel lighting, well, this of course is at your discretion. If you want the panels lit up, you can do so, but it's daytime, it's fairly bright, we don't need any lights on at the moment. Next, the DC power is being provided by the external power, so we don't need the APU selected on at this stage. And if we look at the engine start panel, we need the ignition systems in normal, and the start push button is deselected, and the select switch is in the central position. So all of those indications are normal. Next, looking at the cabin altitude panel. Looking at the aerodrome chart for Jersey, we can see that the aerodrome is 277 feet above sea level. So I'm going to select, which would be about there. We set the landing altitude for our arrival, of course, so that the pressurization system, which is automatically controlled in normal conditions, will automatically schedule the correct pressurization, so that by the time we get on the ground at Jersey, the system will have fully depressurized. We need to make sure that The pressurization switch is in the auto position. The forward outflow valve is in the closed position, and the manual control switch is in the manual off position, so centralized, and we've already set the landing altitude, so the pressurization panel is looking good. External lights, once again, we've got some more controls here. The wing inspection light lights up the leading edge of the wing so we can inspect it at night, and I would recommend that you keep this on for nighttime flying operations, as the leading edge of the wing is actually visible from the flight deck. So during the flight, in nighttime flying operations, you can inspect from time to time the leading edge to make sure there's no ice accretion, and if there is, of course, you can then use the anti-icing system. However, it is daytime, the leading edge of the wing is perfectly visible at the moment, so we'll leave the wing inspection lights off. The collision lights need to be off as well. We'll select those to red prior to engine start, and then we will select them to white on entering the runway. But they can be off for the time being when we're sitting on stand with the engines off. Position lights we've already discussed, they need to be selected on. And the logo light obviously lights up the logo on the tailplane of the aircraft, and this is actually very useful for nighttime flying operations, for keeping the aircraft nice and conspicuous, particularly on the taxi areas of the airport at night. Again, we're in daytime at the moment, it's nice and light, so the logo light not really required, but I would recommend that these lights be selected on, that this light is selected on for nighttime flying operations, even when the aircraft is on stand. Next we have some ancillary controls. The emergency lights need to be in the arm position. This ensures that in the event of a power loss, the lights in the cabin will provide guidance to the passengers to the nearest emergency exit, and they need to be armed for all flying operations. The seatbelt signs, fastened seatbelts need to be on at this stage. If the aircraft were refuelling, then we would leave the seatbelt signs off until refuelling had been completed, and that's just to cover the very, very small possibility of any kind of fire situation during refuelling, so that the passengers aren't belted up while the aircraft is being refueled. They can evacuate as quickly as possible. But we can assume that the aircraft has been refueled, so the seatbelt signs can remain on. No smoking signs are always on. All Flybe flights are non-smoking. And next we come to the test, caution and advisory switch. We're going to test the cautions first of all, to make sure both the master warning and caution lights illuminate, and all of the amber caution lights and red warning lights illuminate correctly, which they have. The next is the advisory section, which, as you can see, lights up all the major advisory bulbs in the flight deck. This is really done to ensure that the bulb hasn't failed, that kind of thing. Most important ones are the fire detection panel lights. You can see all the lights are working there satisfactorily. The de-icing and anti-icing lights. The landing gear lights. The autopilot disengage light. The master warning and caution. Those are really the most important lights to check. Some lights won't illuminate, such as the engine select and engine start lights, but the most important lights are the ones that I've just mentioned. So all of those are working satisfactorily. We can switch the test function off now. Temperature controls next. We can select FA for the cabin temperature, so the flight attendant, as the Americans call it, or cabin crew personnel, can control the temperature in the cabin and the temperature in the flight deck. Whatever you require, we'll keep it nice and warm as it is winter. Next, we need the bleed selection to minimum. This is standard for departure. Making sure that prior to engine start the bleeds are selected off and the recirc fan is selected on. And the final panel then is the AC control panel, which we don't really touch in normal circumstances. The AC electrical generators for the engine should be selected on, and we don't have an AC external power generator, so that can be left off. So we can start on the captain's side now, starting with the side console, and first making sure that the GPWS override switch is guarded and blank, so not illuminated. And next we have a look at the various test functions. So testing first of all the takeoff warning horn, which will sound if a takeoff procedure is initiated without the aircraft being correctly configured for departure. So we're just testing that to make sure that the warning horn sounds. There it is. So that's working correctly. Next we check the air data computers, both systems. So number 1 first. Next we test the stall warning system. Next we check that the nose wheel steering system is off. This has to be selected off prior to pushback in order to avoid damage to the nose wheel steering system. So moving up to the glare shield then. The flight taxi switch, which obviously controls the spoilers as we discussed in the previous video, needs to be in taxi. Stick pusher shutoff and elevator trim shutoff should all be blank. The clock needs to be set with the correct time with the elapsed time or chronometer set to 0. And next we perform a GPWS test. To give an abbreviated test we simply click the push button momentarily, or if we hold the push button for longer than 3 seconds we get the full GPWS test, and we'll do that now.
Glide slope. Pull up. Terrain. Terrain. Sink rate. Pull up. Terrain. Terrain. Pull up. Don't sink. Don't sink. Too low. Terrain. Too low. Gear. Too low. Flaps. Too low. Terrain. Glide slope. Bank angle. Bank angle.
Plus 100. Minimums. Minimums. 2,500. 1,000. 50. 40. 30. 20. 10.
Caution. Terrain. Caution. Terrain. 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 Pull up.
So that test has been carried out satisfactorily. Next we're checking the powered flight control services switches to make sure that they're all blank. And the HSI selected for navigation is on the captain side. You can see the arrow shows which side is currently active, so the captain side is the one that we want and it's the one we have active. And also you can see on the first officer display that the left hand HSI is in command, so that's all looking good. We also have a momentary look at the standby compass, which is showing roughly 110 degrees, and that is confirmed on each HSI. So next we can start setting up the instruments. We update our weather picture from the ATIS, which you can get from VATSIM if there are air traffic control online, or you can get from the weather server that you're using. I'm using Active Sky Next, so I put the ICAO code into the Active Sky Next command window, and it tells me that the weather, we currently have visibility greater than 10 kilometers, Wind 170 degrees 8 knots, so we're still using runway 15. Temperature 14, dew point 11, and we have a QNH of 1022. So we use the barometric setting to set 1022 on the pressure altimeter and the standby altimeter as well. That gives us a current altitude of 340 feet, and if you look at the aerodrome chart on the UKAIP site, you'll see that that correlates correctly with the actual aerodrome elevation for Birmingham, which is 339 feet above sea level. Next we're going to set the altitude reference bug. You can see it's selected decision height at the moment, which we don't need, so we're going to deselect the decision height indication and use the decision altitude function, and we're going to bug the standard thrust reduction altitude of 1,000 feet above aerodrome level. The aerodrome level is 340 feet, as we discussed, or a little bit under 339. So we'll call it 340, and that gives us a bugged altitude of 1,340 feet. So that's the altitude at which we will reduce to climb power and start the initial climb procedure. Also, having a look at the aerodrome charts, we can see the departure we're going to be using, which, as we've said, is the Compton RNAV departure. It has an initial climb out track of 147 degrees, so we're going to set 147 on the heading bug. It has an initial climb value of 6,000 feet. So that's now bugged, and we're now going to set the flight mode annunciator correctly for departure. So we want a standard nose up reference of 10 degrees on the flight director, and we select that using the go around triggers on the power levers. So there we have the go around function giving us 10 degrees nose up. We want to climb out on the initial runway heading using the bugged heading function, so we can see we have heading select. And don't forget, as we've already discussed, it's vital in the Q400 with any altitude instruction to make sure that we have the alt cell mode armed on the FMA, so that the aeroplane will definitely capture that initial altitude. So we have heading select, go around, and alt cell selected with 10 degrees on the flight director. Lateral guidance giving us guidance to the initial bugged heading of 147 degrees, which is the runway heading. So we can say that the flight mode annunciator is now correctly set up for departure. Next we're going to have a look at the engine display. The power values aren't shown at the moment, which is perfectly normal. All the various gauges showing 0 and very low turbine temperature. The engines haven't been running for quite some time, so all that's normal. The oil temperature is normal, no oil pressure at the current time. Again, that's perfectly satisfactory, and the fuel temperatures are normal. So at this stage we've already worked out our fuel figure for today's flight. So we use the Majestic control panel to send all the correct data that we've already calculated as part of the pre-flight planning stage to the aircraft. So we click send data. The sim pauses, as you'll notice, and we should have the correct loading information on the aircraft. So we have a total fuel figure of 1770 kilograms planned, and as you can see on the engine display, we have that figure loaded on board. Moving down to the pedestal, having a look at the FMS initially. We're not setting it up just at the moment, but we're checking the navigation database, which is still in date and perfectly valid. Correct time and date. The initial position is correct, and I've cross-checked that already with the position shown on the aerodrome chart and the correct navigation database date as well. So we can accept that. Next we need to make sure that pitch and roll handles are stowed. Auxiliary pump switches are selected off, and the transfer is selected off. We have flight plan fuel figure of 1770, and you can see that's exactly what we have loaded on the fuel gauges. So the fuel figure has been checked, and we need to make sure that the imbalance, if there is a slight imbalance, it's not too bad, but the imbalance is not acceptable beyond 272 kilograms difference between each tank. So if there is a difference of that kind, then the fuel transfer option will have to be used prior to departure. Standby VHF panel is selected off, we don't need that on at the moment. And next we perform the auto feather test. The full procedure for this has been outlined in the engines video on my channel, so I'm not going to go through each individual element of the auto feather test, but simply carry it out. So there we go, we select it and monitor the indications to make sure they show appropriately. You also have to make sure during this test that the power levers are in disc and the fuel levers are off. So there we go, that's the test pass. We can now deselect the auto feather option. So the emergency brake is currently selected to park, and we need at least 500 psi on the parking brake, and you can see that we have well in excess of that, so the parking brake should work satisfactorily. The gust lock, which is just forward of the power levers here, is selected on at this stage to stop any unwanted control movements on the ground. Power levers are selected in disc, fuel levers are selected off, and the flap lever is 0, and the flap indication showing 0 as well. The stabilizer trim is here on the very left hand side of the throttle quadrant, and we need to check it for full and free movement. So initially I'm just going to cycle the stabilizer motion, and as I do that you'll hear the master caution going off. This is perfectly normal, and you'll also hear the stabilizer motion sound playing on the overhead speaker. We can use the Q400 control panel as a load sheet. Obviously in real life this would be a teleprinter generated document which would be given to the pilots by a dispatcher, but we don't really have that option in the sim, so we can use this as our load sheet. And here you can see the zero fuel mass is 22.9. We have a max of 26.3, so we're well in our maximum zero fuel mass range. The estimated takeoff mass is 24.7, and again max of 29.5 means, or rather 29.6 as we round up, we're still well below our limiting value. And our estimated landing mass is 23.7. We have a maximum of 28.1, so we're all well within limits. And the next index we have to look at is the MAC percentage, which gives us our trim setting essentially. So for centre of gravity MAC percentages forward of 13.9%, we need to use the aft end of the elevator trim takeoff range. If the centre of gravity MAC percentage is aft of 36%, then we need to use the forward end of the takeoff range, and anything between 13.9 and 36% can simply use the central part of the takeoff elevator trim range. We have an MAC percentage of 31.4% for our flight, which means that the elevator trim can be set to the mid part of the takeoff trim range. Moving further down, making sure that the weather radar is selected off, and at this stage we'll want to select the correct frequencies on the radio and also the navigation aids as well. So I'm on VATSIM, of course. So I have the Unicom frequency 122.8 set. There is no air traffic control online at the moment. And for nav2, we can set the emergency frequency 1215, which is guarded normally throughout the flight. The departure itself, the Compton 1 Lima from runway 15 at Birmingham, is actually an RNAV1 procedure, as you can see, therefore doesn't require any raw data backup. So you don't need necessarily to tune backup navigation aids as you would with a conventional standard instrument departure. Nevertheless, as a backup function, should we need to return to Birmingham, I'm going to set the ILS 110.1 on both sides, and I'm going to select the correct inbound track of 147 degrees. So that's set on both sides. ILS2 and ILS1 both have the ILS for runway 15 set and the correct inbound track selected on the HSI. And that is simply a backup should we need to return to Birmingham in the event of a malfunction. I'm also going to set the local NDB. For those of you familiar with the area, you'll probably know the Bravo Hotel X-ray 406. I'm going to set that on ADF1. Transponder can be in the standby setting at the moment, and we can be in and have the standby squawk of 2000 set. And if I line select against the transponder setting and select the expanding option, we can test the TCAS to make sure it's working correctly.
TCAS system test OK.
So once we have that oral tone, we can then be satisfied that the TCAS is working normally, and we go back to page 1 to the normal frequency page on the ARCDU. Next, we need to exercise the various trim controls, so exercising the aileron trim and the rudder trim to make sure that they have full and free movement. And then making sure that the aileron trim is centralised, and the rudder trim, you'll notice we have about a needle's width to the right of centre, and this is to offset the yawing motion that's concomitant with high power settings in the Q400. So for takeoff, we'll have the rudder trim selected slightly to the right of centre. Moving on to the first officer's side now then. The clock is correctly set on his side with the chronometer and elapsed time both zeroed. The anti-skid switch is on, and we're just going to perform a test function which will illuminate the master caution lights and also the inboard and outboard anti-skid caution lights on the caution and warning panel. So there goes the master warning lights, and there goes the inboard and outboard anti-skid lights, which eventually extinguish, and the switch can then be selected back to the on position. Moving to the side console for the first officer now, you can see that the oxygen is in the green band. We need it to be at least 1300 psi for dispatch. The outflow valve selector is normal and guarded, and the various lights can be selected as required. And that completes the cockpit preparation check. So now that we've completed the cockpit prep, we can run through the checklist. So the documentation is checked, safety equipment's tested and checked, the circuit breakers we've checked, the landing gear and pins checked, engine intake doors are open, batteries checked, main bus tie is in tie, fire detection and smoke we've tested, DC external power or APU, the DC external power is on, battery temperatures are checked, bleed 1 and 2 off, APU bleed is not required and off, the bus voltage we've checked, recirc fan on, pressure and packs are set and checked with the packs in the auto position, the avionics we've checked, and the system tests, the air data computer, the stall warners, the takeoff warning system, the anti-skid, the autofeather and the TCAS have all been checked, and that's the cockpit preparation check complete.